Ratio. Ratio is the word, okay, that we're looking for there in that blank. Since it tells you right after that, hello people, come on. So a ratio is just simply a fraction, right? A little division problem, okay? Now in sections 5.2 and 5.3 today, we're going to talk about rational functions. We're going to learn some skills on how to graph them and things like that, okay? All right, so to get the graphs, we'll need to remember some basic skills. How to find the domain. We'll need to do some factoring, some simplifying, and some other things in order to do this, okay? Now, these problems aren't necessarily hard, but you'll need to do them in a systematic, organized way, okay? Think about what you're given and what you get and what it means to the graph, okay? So that's where we're heading. All right. So let's begin. So a rational function is of the form r of x, which is equals p of x over q of x, okay? Where p and q are polynomials, and q is not the zero polynomial, which would make sense, because if that were the zero polynomial, this would be undefined and we'd be over quick. Okay. So the domain of a rational function is all real numbers except those that make the denominator 0, right? Or make q, in this case, equal to 0. Okay, so why can't q be equal to 0? Because dividing by 0 is undefined. All right, so now we're gonna let's look at the pretty much the simplest rational function we can have, and then we'll go from there. So I want to sketch the graph, identify the asymptotes and the domain, and go from there. Okay. All right. So first of all, what is an asymptote? Let's define that. I think we have already in here, but let's just redefine it. What's an asymptote? Okay. Since he said it real quiet, I'll say it loud. Okay. But you're exactly right. Okay. An asymptote is a line that the graph approaches but never touches. Okay. So let's talk domain here first, and then we'll start doing some things. So what is the domain of this function? What can't x be? X can't be 0, right? So x can't be 0. Now let me give you, okay, a little piece of information. Wherever the domain is undefined, in this case it's 0, that's where you have a vertical asymptote. So on this graph we have a vertical asymptote at x equals 0. Right there. Okay. So now before we get to horizontal asymptotes, let's go ahead and graph this. Okay, and for now, for our graphing skills, let's just plot some points, okay, in order to graph this. So we'll make ourselves a little xy table here. So we know x can't be 0, so let's make x 1. So if x is 1, what is y, or f of x? Yeah, that's 1. Okay? So we know we're here. What about if x is 2? Then it's 1/2. What about if x is 1/2? If x is 1/2? Yeah, good. 1 over 1/2 is 2. So now we're here. So our graph, that part's going to look like this. Okay, will y ever get to 0? Yeah, there's nothing I can put in to make y 0, right? So guess what y equals 0 is? Another asymptote. Good. Okay. All right. So now, if we go x is -1. If x is -1, what's y? -1. If x is -2, what's y? -1/2. Okay, notice we're getting similar stuff. So this one's going to look like this. Okay? Well, there's your graph right there. And you're going to find with rational functions, okay, that they make those kind of shapes a lot. Those kind of diagonal looking parabolas or whatever, okay? Though they're really not parabolas, but anyway. Okay, so a couple words here again. So a the word proper, okay, in this case means the degree of the numerator is lower than the degree of the denominator, okay? And then an improper rational expression, okay, is where the degree of the numerator is, yeah, greater than or equal to, or is equal to or greater than the degree of the denominator. Okay? So now with that definition, let's see what's proper and improper. Okay? Alright, so x minus 1 over x squared minus 1. Proper, improper. Don't start this. That one is proper. Part B. Degree is the same, but is it proper or improper? Improper. Good. And part C? Definitely improper. Okay. Okay, so in graphing rational functions, we use proper and improper to help us find the horizontal and oblique asymptotes. And another word for oblique is slant. So you'll hear me use both terms. I use them interchangeably. So if I say slant asymptote or oblique asymptote, I mean the same thing. And basically what that means is it's neither vertical nor horizontal. Okay, it's got some slope to it. Okay. All right. So if the rational function is proper, which means the degree on the top is bigger. Sorry, the degree on the top is smaller. Okay, then we have a horizontal asymptote at 0. So if you look at the one that we just did, 1 over x, right, the degree on the top was smaller, so we had a horizontal asymptote at 0. That is always the case. Okay, now there's two possible outcomes if it's improper. Okay, the good type of improper, if you will, where the degrees are the same. Okay. Then you have a horizontal asymptote at the leading coefficient of the top over the leading coefficient on the bottom. Okay? And we'll do examples of all this so you can see it. Okay? But again, if the degrees are the same, then you have a horizontal asymptote at what's called the quotient of the leading coefficients. Okay, to make me sound all smart and stuff like that. But it's basically the leading coefficient of the top over the leading coefficient of the bottom. Okay? Now, what we call the bad type or the difficult type, right, is if the degree on top is bigger. Okay? Now, if this is the case, then we have to use long division. And we have to divide it out, and then whatever our answer is, okay, that's where we have an oblique or a slant asymptote. And that's oblique. Okay, and we already talked. Okay, so example 3 here now, we want to find our asymptotes. Okay? Or just in this one, we want to find the horizontal or oblique ones. Okay? So part A, so these ones we just dealt with. So we have a horizontal asymptote at 0. Or you can say at y equals 0. Okay? Again, because the degree on the top is smaller. Okay? When the degrees are the same, on part B, it's our leading coefficient. So what's the leading coefficient of the numerator? It is 2, correct. What's the leading coefficient of the denominator? 1. So we have a horizontal asymptote at 2 over 1, or at 2. Okay? All right, part C, now we have to divide this one out. Now you can do long division with something like this, though. Well, what else can we do? Yeah, we could do synthetic division on this one, okay? But we're gonna do long division anyway, just so you can practice and remember. Okay? Even though synthetic division would be a lot quicker on this one, that is correct. Okay? So, all right. So again, just to recall, all right, when we long divide, we look at the first terms of each one. So we have an x here and an x squared here. So x times what is x squared? X. So that comes up here. And then we take x times x plus 2 is x squared plus 2x. Now we're going to subtract them, or we're going to change our signs. So that goes away. X minus 2x is minus x, and then we bring down minus 3. Now x times what is minus x? Minus 1, right? Okay, now we're done. That's all we have to do when we're finding oblique asymptotes, okay? You now have an oblique asymptote at x minus 1. We don't care what the remainder is or any of that stuff, okay? We don't have to completely divide it out. As soon as we get that number up top there, we're done, okay? So in this case, we have an oblique asymptote at x minus 1. So if I were to graph this, okay, which we're not going to right now, but I would graph x minus 1, so you come down 1, up 1, over 1. So it would look something, I would have an oblique asymptote that looks something like that. And then my graph would go around there. And we'll show you what those look like as we go, okay? All right, now, so first step, finding horizontal and oblique asymptotes. That's step 1. Step 2, we need to find our vertical asymptotes, okay? And the vertical asymptotes are really simple, okay? Basically, and it's like I told you before, vertical asymptotes are wherever your denominator is 0, okay? Or whatever is not, whatever makes your domain undefined, or the rational expression undefined, okay? That's where you have a vertical asymptote, okay? So now you can do this by, oh, I need to mention holes as well. Forgot about that, okay? Now, we have there are holes in our graph where we have the same factor top and bottom. So if I factor the top, factor the bottom, and I get, let's say, x plus 2 on top and x plus 2 on the bottom, then I'm going to have a hole at negative 2. Because if I were simplifying that rational expression, if I had same thing top and bottom, I'd cancel, right? I'd cancel the x plus 2's and move on, okay? But technically, negative 2 can't be part of our domain because it's in our denominator, okay? So, but instead of having an asymptote there, if I have the same factor top and bottom, I have what's called a hole, okay? And we'll show you how we deal with those here in just a second, okay? So again, any number that makes the denominator 0 is not in the domain, okay? So if the factor that produces a 0 cancels, then there's a hole in that graph. If the 0 doesn't cancel, then there is a vertical asymptote at that value, okay? All right. So let's do example 4 here. So we have our same 3 functions. So we want to find the vertical asymptotes and the holes of each of these and then state the domain. Okay? So part A, okay, the top is simplified. Can I factor the bottom though? And what does that bottom factor into? Yeah, x minus 1, x plus 1, correct? X minus 1, x plus 1. Okay? So what is my domain here? What can x be? Plus and minus 1, right? So, for my vertical asymptotes, okay? Now, here's one thing. With horizontal and slant asymptotes, you only have one. Okay, there's only one horizontal or one slant or oblique asymptote in a rational expression. Vertical asymptotes, you can have several, okay? All right, so on this one here we have a vertical asymptote at x equals negative 1, and we have a hole at x equals 1. And again, we're gonna get to graphing these things, so just be patient, okay? But we're just showing you how to find everything now, and then we're gonna put it all together on a graph. Greg, did you have a question?
Did you say that x can equal plus or minus 1, right?
Correct, as your domain, correct.
So can you have so with the whole
Okay, so again, so are we clear on where the hole is, on why it's a hole at 1 and an asymptote at negative 1? Are we okay with that for now? All right, okay, so now let's look at part B. And again, what we have to do, we have to factor the top if we can, factor the bottom if we can, and then see if we have any common factors, okay? So the top on part B, and I did not leave much, we did not leave much room here, okay? Going quickly, so we got 2x and x. Yeah, it's got to be 4 and 1, 4 and 1. Oh my gosh, plus and minus. So we have 2x minus 1 and x plus 4. Okay, and then the bottom factors into x plus 4 and x minus 2. Okay. I want to keep going on this, even though that's not working because we're recording this so you can see it again, okay? So your factor on B should be 2x minus 7 times x plus 4, or sorry, 7. 2x minus 1, can't even read my own writing. 2x minus 1 times x plus 4, and then the bottom is x plus 4x minus 2. So if we're talking holes and vertical asymptotes, we have a vertical asymptote at 2 and a hole at negative 4. Good. So a vertical asymptote at 2 and a hole at negative 4. Okay, so the question was asked, is 1/2 1, and the answer is no, because the numerator doesn't have anything to do with it unless it's a common factor, okay? Because the numerator can be 0. A 0 numerator is totally fine. Okay, it's a 0 denominator where we get in trouble. All right. Okay, so part C. Now this is actually the easiest one. What do we got? Except we need to determine is it at negative 2? Is that a vertical asymptote or is that a hole? And how do we determine it? We factor the numerator. Okay, so we factor that, and that factors. Let's see. X, does it factor? 3 and 1. No, that doesn't even factor, does it? So at negative 2, we have what? Is it a hole or is it a vertical asymptote? It's a vertical asymptote. Okay, it's only a hole if you have the same factor top and bottom. So, oops. So here we have a vertical asymptote at, and I really should be putting x equals negative 2, like that. Okay. We continue. All right, so finding the asymptotes and holes is a major part of understanding irrational functions and their graphs. However, we can't forget all the other important things we learned about, like intercepts, end behavior, multiplicity, blah, 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 blah. Okay, so now the next example here, we want to find the x-intercepts of each of these functions. In other words, find the zeros, okay? So, how do we find the x-intercepts? We let r of x equal what? 0, right? When it crosses the x-axis, y is 0. Are we all okay with that? Okay, so on part A, I'm gonna let r of x equal 0. Okay, well if that is 0 then equals, so here let's put a big 0 right there. Okay, so if that is 0 then, alright, how do I solve for x? What's the first step? Times both sides by x squared minus 1. Well, guess what that does? It goes away. We love zeros in math, right? They wipe stuff out. So then we get 0 equals x minus 1. So what does x equal? X equals 1. There's your x-intercept right there. At 1. Okay? Except for in this one, what do I have at 1? Look up the page a little bit. We have a hole at 1. So it's going to go right to it. It's going to go right to 1. We're going to put a little hole in, then it's going to continue on right after that. And again, when we graph this, we'll show you that, because I think we graphed this actual one, if I remember right, okay? But for now, our x-intercept is at 1. Except it's not, because there's a hole, but anyway. Okay? All right, so basically, all right, so part B then. Again, we make this 0. We times by the denominator, and what happens? It goes away, right? So, are we seeing a pattern here? So if we want to find the x-intercepts, we just set our numerator equal to 0 and solve it. That's all we got to do, okay? So now we factor that numerator, and we get, what was that again? 2x minus, no, 2x, yeah, minus 1 and x plus 4, right? So where are our x-intercepts here? At 1/2 and negative 4, except for what do we have at negative 4? We have a hole there. Okay. All right, so we're getting this, right? So part C then. So 0 equals, now does that numerator factor there? It doesn't, so what are we going to do? The quadratic formula, very good. So our x equals negative b plus or minus the square root of b squared minus 4 times a, which is 1, so we're not even going to write it, times c all over 2a. So that's, let's see, 13. So here your x-intercepts are 1 plus negative 1 plus or minus the square root of 13 all over 2. Now, if you're asked to graph that, obviously we want to put that in decimal form because we have no clue where those are right now. Okay? So put them in decimal form. So now you understand there are two answers there, right? Negative 1 plus root 13 over 2, and then negative 1 minus root 13 over 2. And if you can't see it that way, split them up and write it as two separate answers. Don't write it together, okay? All right, now, with all that, that's pretty much what we need to graph these, okay? So here are your steps. So we got 7 of them, okay? Locate your horizontal or slant asymptotes. Factor the denominator to find the domain, and then you can factor the numerator and cancel any common factors, and then that'll give us our vertical asymptotes and our holes. So again, vertical asymptotes are zeros in the denominator that don't cancel. Holes in the graph are zeros in the denominator that do cancel. Then we need to find our x and y intercepts. Okay? Then we draw our asymptotes, the holes and the intercepts on the graph and all that stuff. And then we can use an a small little xy table to determine a couple of points so we can figure out where the function is positive or above the x-axis or negative below the x-axis. Okay? And then we put it all together and start sketching that graph, okay? And then oftentimes you'll be asked to label the important features, like label the x-intercepts, label the asymptotes, okay? Things like that, all right? All right, so let's rock and roll. So we're going to graph this first one, all right? So now with this one, we've already got all the information, right? We did it on that last page. Okay, so what's step 1? Flip back, it finds your horizontal or slant asymptote. So where's our horizontal asymptote? Good. At 0. Okay? And if we have a horizontal asymptote, it means we don't have a slant asymptote. Okay? So what was step 2? What was it? You need to factor the denominator, right? So let's factor the denominator. So that factors into x minus 1, x plus 1. So where are, and then that's over x minus 1. So where's my vertical asymptote? At 1. And where's my hole? At negative 1. Okay? All right, next step. Wait, did I do that wrong? I did do that wrong. That's negative, and that's positive. Good call. Thank you for correcting me, because that would have sucked if we had gone all the way through the graph wrong. Then I'd have been really irritated with you guys. Okay, so what's the next step? What's after vertical asymptotes? Look back and I'm making you look back and tell me. What's the next step? The domain. Wait, I'm hearing several things. Tell me what it is. Okay, so we just found our vertical asymptote and hole. So what's next? The y-intercept. X and y intercepts, is that right? Is that next? Okay, let's find x and y intercepts, okay? So, what is your x-intercept? X-intercept is 1, good, okay? Except for we have a hole there. Okay, what is your y-intercept? How do we find the y-intercept? We make x 0, so what's your y-intercept? I got negative 1 over negative 1, so that is 1. Okay? Good. Okay, turn back now. What's the next step? Okay, so now we're ready to start putting it together. Okay, so let's graph our asymptotes and go from there. All right, so we have a horizontal asymptote of 0. That's easy. It's our x-axis. We have a vertical asymptote at 1. Oh, gosh, dang it. At negative 1, so like I said, you guys got me all messed up now. Okay. We have a hole at 1, x-intercept at 1. So our x-intercept is supposed to be at 1 right here. But what do we know about our x-intercepts anyway? That's an asymptote, right? So we're not going to have, so it's not going to be there. So that we don't, in other words, there is no x-intercept. Okay? Now where's our y-intercept? 1. Okay, we can put that one on there. Okay, there's that point. All right, now what's the next step? So we've identified everything. And we don't have to write our hole here because that hole occurs right on an asymptote, so we don't even have to write it. We don't have to worry about that hole. Okay. So now we need to make an XY table, correct? And let's plot a couple points. See where it is positive and negative. Okay, so we've already got when x is 0, y is 1. So now we can't do x is 1. So what do you want to do? Should we try x is 2? Okay, let's say, so when x is 2. So we're going to plug in real quick. So 2 minus 1 is 1. 2 minus 1 is 1. 2 plus 1 is 3. So I get 1/3. So when x is 2, y is 1/3. So we're right here. So guess what this is going to look like? Okay, our little curve, just like that. Okay? Because when x is all those values, we're good to go. Okay? Okay, now let's come on the left side of our of that vertical asymptote. So let's say x is, should we just go -2? Okay, what's that?
So it can't be negative.
Right, can't be -1 because that's a vertical asymptote there. So we're going to hop to -2 and see what we get. Okay, so -2 minus 1 is -3. And then -3 and -2 plus 1 is -1. So what's my answer here? It is -1. So we're at -2 and -1. So it's right here, which means this one's going to look like this. And there we go. The first graph of a rational function. I'm so proud of you guys. We'll handle them all. Okay, so example 7 here. Okay, so first step, horizontal asymptote. So is this proper or improper? This is proper. So where's my horizontal asymptote? It's 0. Good. This one we'll kind of go as we find them. All right, next step, we got to factor the denominator. So what does x squared minus 9 factor into? Yeah, x plus and minus 3. Good. All right, vertical asymptote. At where? At x equals what? Yeah, plus and minus 3. Hole. Do we have any holes? Nope, we got none. Okay. X and y intercepts. Okay, x intercepts. We don't have any, right? The x-axis is an asymptote, so there are no x-intercepts. Okay? Y-intercept. Make x 0. Where's my y-intercept? -2/9. Oh, that's kind of yucky. Oh, I didn't sketch in my vertical asymptotes. Forgot to do that. Sorry. Okay, so the y-intercept is at -2/9, so it's like right there, give or take. Okay. All right, now we need to pick some points. Right, is there anything else we need to do? I think that's it, okay. All right, so we need to pick some points. So let's pick one over to the right, clear to the right of our vertical asymptote there, so something bigger than 3.
4.
Hey, 4, look at the creativity juices are flowing today. So if x is 4, what is y? Yeah, if x is 4, y is, let's see, that's a 7, that's a 1, so it's 2/7. Good. So if x is 4, y is positive, and that's basically what we want. So we know then it's going to look like this. Okay. So let's pick, let's go on the other extreme side now. Let's go -4. Okay. So if x is negative 4, what's y going to be?
2 7.
Hey, weird. Okay, because negative 4 plus 3 is negative 1, and then negative 4 minus 3 is negative 7, so negative 1 times negative 7 is positive 7. So that one's also going to look like this right here. Oops. Not crossing over that asymptote. Okay? Now we got to figure out the middle, and this is where it gets a little tricky. Okay? So make sure that we are doing this correctly. Okay? All right, so let's pick some points in the middle now. Okay, well, okay, now we've already got our y-intercept right there, so that's good. So let's pick x as 1. Okay, so what have I got here then? So 1 plus 3 is 4. 1 minus 3 is negative 1, so I have 2 over 4 times negative 1, which gives me negative 1/2. So when x is 1, y is negative 1/2. So we're right here. Okay, what about 2?
Negative 2 fifths.
Okay, so if we have 2, right, 2 plus 3 is 5. 2 minus 3 is negative 1, so it gives me negative 2/5. Okay, so at 2, so now we're at negative. Okay, negative 2/5, so that is, oh, this is looking weird. Are we doing this right?
Well, I think
You guys are wrong.
no.
Is 1 wrong?
It's 1 negative 1/4.
Yeah.
Oh, negative 1/4, because that was because it was 2. Oh my gosh. Seriously, people. You got to catch me on this way sooner. I heard negative 1/2 and just wrote it down. So that's negative 1/4, right? Okay. Whew. That's much better because this was looking not how I wanted it to. Okay. Try this again. So there's negative 1/4, negative 1/2. Okay, so now let's do negative 1. Okay, so if we do negative 1, then negative 1 plus 3 is 2, and negative 1 minus 3 is negative 4, so we get negative 1/4. So what's this going to look like? Just like that. And there's your graph. So now, the end behavior stuff, the stuff on the outside is really easy. Pick a point that's going to always be positive or excuse me, always be above the asymptote or always be below the asymptote. The middle stuff, though, is where it gets screwy. Okay? Now this one turned out nice and clean for us, so we're okay there. But some aren't going to necessarily be so nice and clean. Okay? Alrighty, let's rock and roll here. Okay. Horizontal asymptote
X equals 0.
at x equals, no, it's y equals,
Y equals 0.
at y equals, now the degrees are the same, so it's at 2 over 1 or 2. Okay, we got a factor now. So what can I factor out of the top? 2x, and I'm left with x minus 3. Okay, factor the bottom. X and x, 4 and 2, plus and minus. Okay, cool. All right, vertical asymptotes. At x equals, that's a 4. At, oh my gosh, that's worse. That's the one thing with this program. I've got another one that writes so clean and nice, and this one I struggle with writing. So, okay, so our vertical asymptotes are at negative 4 and positive 2. Let's get those in. Any holes? Nope, no holes. Okay. So, what's next? Intercepts. Okay. So where is my x-intercept? Intercepts, I should say.
0, 0.
At 0 and at 3. Good. which means, guess where my y-intercept is? At 0, right? If the x-intercept's at 0, the y-intercept has to be at 0. Am I going to have more than one y-intercept? No, because it's a function, right? Can only have one y-intercept. So we're done with that. So our x-intercepts are at 0 and 3, and this means our y-intercept is also at 0. Okay, now, okay, on the far right, we've already got a point here, so it should look something like this. Okay. And if you want to test another point, test one. Do x is 4. Okay, and you can look at that. So 2 times 4 is 8. 4 minus 3 is 1. 4 plus 4 is 8. 4 minus 2 is negative 1. Oh, wait a minute. Oh no, 4 minus is 8. Oh wait, 4 minus 2 is 2. Where did I get negative 1 from? Oh my gosh. So we get 8 over 16 or 1/2. So, okay, I should have gone a little steeper. But anyway, that's the essential shape. Okay, so let's go less than negative 4. So negative 5. Okay. So if I go negative 5, then I get a negative here and a negative here, and a negative times a negative is a, well, let's see, so negative 5 times 2 is 10. Let's just do it right. Negative 5 minus 3 is negative 8. Negative 10, sorry. So up top we have negative 80. Bottom. Negative 5 plus 4 is negative 1. Negative 5 minus 2 is negative 7. So we get 80 over 7, or we get 10 and some change, right? Or 11 and some change. So we're way up here. That's what that part's going to look like. Okay. We're above the asymptote, and again, when we're out far right or far left, okay, we just have to look at whether we're above or below the asymptote, and then the graph will look like that. Okay. All right, now the middle. Okay, we know we're right here at the origin. Okay, let's pick some other points. So let's pick x as 1. Okay. So if x is 1, we have 2 times 1 is 2. 1 minus 3 is negative 2, so we have negative 4 up top. And then 1 plus 4 is 5. 1 minus 2 is negative 1, so we have negative 5 on the bottom, so that becomes 4/5. So 1 and 4/5. Interesting. Okay, let's pick negative 1. Okay, 2 times negative 1 is negative 2. Negative 1 minus 3 is negative 4. Okay. Negative 1 plus 4 is 3. And negative 1 minus 2 is negative 3. So what does that give me? Negative positive 8 over negative 9, so negative 8/9. Right here. Okay, let's go negative 3. See what that's going to do for us. Okay, so 2 times negative 3 is negative 6. Negative 3 minus 3 is negative 9. Over negative 3 plus 4 is 1. Negative 3 minus 2 is negative 5.
Negative 3 minus 3 is negative 6.
Where do we get? Oh, gosh, I times that together. My goodness. Thanks, guys. So negative 3 minus 3 is negative, so it's negative 6 times negative 6. And okay, beautiful, thank you. Okay, on the bottom, so negative 3 plus 4 is 1, negative 3 minus 2 is negative 5. So I get positive 36 over negative 5, which is?
About 7.
Yeah, negative 7, so we're way down here, right? Okay. Okay, so now we know our graph's gonna come like this, right here, but what's it gonna do here now? So it's either gonna come up here, or it's gonna whip right back down around here. I think it does that, but I'm not sure, but let's check. Let's graph one more point, and this is gonna be a little yucky. So let's graph, let's see, that's one, so let's do 1.5. So I'm gonna need some calculator help here, people. Okay, so 2 times 1.5 is 3. Okay, 1.5 minus 3 is negative 1.5. Over 1.5 plus 4 is 5.5. And 1.5 minus 2 is negative 0.5. So we know our answer is going to be positive, but positive what? Okay? Help me out here. So 3 times 1.5 over 5.5 times 0.5. Calculator people, help me out. What is it? 1.6. Somebody verify that for me, please. Well, that sounds pretty good. I wonder what that is going to look like. I'm curious now. Ah, so that doesn't go. Why won't that erase? Yeah, so it's actually going to come up and it's going to head up like this. Okay. So now the question is, why does it cross that horizontal asymptote right there? Okay. All right. Yes, because and that's exactly right. When you're in the middle, you can break the rules, the horizontal asymptote rules. Vertical asymptotes, you can never break them. Okay, that's because it's undefined. But the horizontal asymptote is mainly for the end behavior out here, far left and far right. In the middle, it actually can cross there. Okay. All right. All right. So now with again 3x squared minus 3x over x squared plus x minus 12. Okay. So let's okay, so where's our horizontal asymptote? At 3, good. Oh, it's weird that I want to erase that. I don't get that. Okay, vertical asymptote. Okay, we got to factor first. So we factor a 3x out here, and we get x minus 1. And on the bottom, that factors into x plus 4 and x minus 3. So vertical asymptote's at x equals negative 4 and x equals positive 3. I have to shrink my graph, shrink this. Okay, hang on. All right, any holes? Okay, at the top we got 0 and 1, bottom we got negative 4 and 3, so there's no holes. Okay, so let's go x-intercepts. So where are the x-intercepts? At 0 and at 1. Okay, which means our y-intercept is at 0, obviously. Okay, all right, let's pick some points. Okay, let's pick bigger than 2, so let's pick 3. All right, so 3 times 3 is 9. 3 minus 1 is 2. Please check me on this because I can't seem to get this right. 3 plus 4 is 7. Oh, we can't do 3. Duh, that's a... Again, check me on this. I was thinking that was a 2. Okay, let's check. Let's do 4. Okay, 3 times 4 is 12. 4 minus 1 is 3. 4 and 4 is 8. 4 minus 3 is 1. So we get 24 over 8. no, 36 over 8, which is, okay, so that's bigger than 4. And that one, the horizontal's at 3. So we are up here somewhere. Okay, so this one's going to look like this. Okay. Okay, so let's pick one less than -4. So we'll go -5. Okay. 3 times -5 is -15. -5 minus 1 is -6. Okay, and then -5 plus 4 is -1, and -5 minus 3 is -8. So my answer is big, right? 15 times 6 is 80, so my answer is 10. 90, so my answer is bigger than 10. Yeah. So that means we are up here. I've got to fix the proportions on that, obviously, because that looks really crappy. Okay, middle. Got our x-intercepts here. We got to see what else it does, though. So we've got x is 0, x is 1. Let's go x is 2. So 3 times 2 is 6. 2 minus 1 is 1. 2 plus 4 is 8 2 plus 4 is 6. And then 2 minus 3 is -1. So we're at -1. So we're down here. Okay. Let's do -2. Okay. So 3 times 2, -2 is -6. -2 minus 1 is -3. -2 plus 4 is 2, and -2 minus 3 is -5. So we get 18 over -10. So that's -1 and some change. 1.8? Thank you. Okay, so this one is going to look like, it's going to come up here somewhere and then come back down, look like that. Okay. Sweet. Okay, so example 10 here. What should we do first with that? Take that numerator, yeah, and write it in descending order. Okay, so we're going to get, and I'm going to factor that -2 out as well. So we get -2x minus 4. We're going to yank a -2 out of that and make it x plus 2 over x plus 1. Okay. All right, horizontal asymptote at -2. Vertical asymptote at -1. Any holes? No. Okay. X-intercept. -2. Good. Y-intercept. Make x 0. Where's your y-intercept? -4. Good. All right. Okay. Pick a point. Let's say x is 1. Okay. In here, 1 plus 2 is 3. 3 times -2 is -6, and then 1 plus 1 is 2, so we get -3. So 1 and -3. Is that right?
The red one should be down.
Not here.
Oh, the red one's on the wrong spot, right?
Yeah.
That one is at
Down -4.
-4. Oh, 1, 2, 3. Oh, so this one's down here. Okay. So now we know that one's going to look like that. Okay. So let's pick -3. So -3 plus 2 is -1. -2 times -1 is 2. And then -3 plus 1 is -2, so we get -1. So 3 and -1. Right there. So this one's going to look like this. That's what most of the ones will look like when you do. Wow, I missed on the bottom one, didn't I? It is one of those days. There we go. Okay, so horizontal asymptote here. Oh, it's an oblique asymptote, right? Okay. So let's figure out where it is. So we're going to divide here. We'll do our little long division. Now, what I'm going to put 0x in here. Why am I going to do that? Yeah, because it's a placeholder. We have to count for every power from x squared on down to 0. Okay? All right, so x times what is x squared? X times x is x squared. That goes away. Bring down 0x. Okay, we're done. It's x. It's y equals x is our oblique asymptote. Okay. Okay. So now what about vertical asymptotes? Yep, at 0, right? Okay, so there's our asymptotes. All right, this ought to be funky. Okay, x-intercepts. Where at? At positive and -1. Good. Y-intercept? Nope. Where do I have an asymptote, people? I have an asymptote at 0, right? So do I have a y-intercept? There is no y-intercept. Okay. Yeah, we're going today. Of course we're going. Come on. Okay. So again, let's pick a couple points and check it out. So let's pick x is 2, shall we? All right, so 2 squared is 4. 4 minus 1 is 3. So we have 3 over 2, so we're at 1.5. So x is 2, we're at 1.5. So right there, so this one's going to look like this. I should do that in a different color, darn it. Okay, let's pick -2. Okay, so -2 squared is 4. 4 minus 1 is 3. And 3 over -2 is -1.5. -2 and -1.5. So now this one looks like this. And there we go. So let's find it. Now, do you want to do synthetic division real quick on this one?
Yeah.
Okay, let's do that. So we've got 1, 1, and -3. 1, -2, -1, 2, and -1. But again, remainder doesn't matter. So we have one at x minus 1. That's where your oblique asymptote is. Okay. What about vertical asymptote? Need to bring this out a little more. Okay. X-intercepts? What? Oh, yeah, yep. Oh, we got to do the quadratic form. Oh, yuck. Now, we already did that earlier, right? Tell me we already did that on this one. It looks familiar. Did we do it? Yeah, so where are our x-intercepts? At -1 plus or minus square root of 13 over 2, correct? Okay, calculator people, get on that for me. Where's your y-intercept, by the way? At -3 over 2, right? Well, we make x 0. So your y-intercept is at negative 3 over 2. Or right there. There's your y-intercept. Let's make that a different color, actually. So roughly right there's your y-intercept. Okay. So what about x-intercept? So what's negative 1? Okay, so root 13's about 3. Well, about 3.5-ish. 3.6 maybe.
1.3 and negative.
Say it again.
1.3 and negative 2.3.
Okay, so 1.3 and negative 2.3. Okay, so we're here. And we are here. Okay. All right, we're starting to get the hang of this a little bit. Wrong one. Should we do one more? Forgot to record all that. Okay, so somewhere over here where x is 4, we're going to have a hole. Okay? All right. X-intercepts. Oh, we were doing so good. Lose you all. Okay, so where are we at here? X-intercepts. Correct? Okay, so where are the x-intercepts? Okay, look at your numerator, right? So they should be at 4 and 1, correct? But what do we have at 4? We have a hole, so our only x-intercept is at 1. So put a dot there. Okay, what about our y-intercept? Yeah, y-intercept is at negative 1. Okay, let's pick some points. So let's pick x equals 3. Wow, we got through the whole period. Sorry about that, guys. So if x is 3, I got 3 minus 4 is negative 1. 3 minus 1 is negative 4. Okay, so we pick 3. So 3 minus 4 is negative 1. 3 minus 1 is 2. And then, now, let's pause here for a second, okay? Even though we're looking at those awesome movies. Okay, if once I've established where my hole is, okay, and we start picking points, do we have to use the x minus 4s here on this one? We don't, because we know that they're just going to cancel out anyway, right? So you can actually, now you can cancel, we know there's a hole at 4, you can cancel those x minus 4s. Okay, get rid of them. So now we only have to deal with x minus 1 over x plus 1. Okay, so again, if we pick x is 3, 3 minus 1 is 2, and then 3 plus 1 is 4, so when x is 3, y is 1/2. So again, so have that open circle at 4, and then just on the other side, pick a point, pick like negative 2 or something. And negative 2 minus 1 is negative 3, negative 2 plus 1 is negative 1, so we're at 3. And we're done.